Hey everybody, we're going to work on solving linear systems, and more specifically we're going to solve the substitution method. Okay, so we learned the graphing method already, and we'll learn the addition method next, but for now we're going to learn just the substitution method. Alright, so the basic idea of the substitution method, okay, is you're going to have step one, you want to get one variable alone. And then step two, you want to put that into the other equation. Don't put it back into the original equation. I'll show you what I mean about that in just a second. So here's an example of what we're talking about. We have two equations, one on the top and one on the bottom. If I look at this top equation, I need to solve for a variable. Now I'm going to do AND's method and make sure that I have ones in front of both of these numbers and down here. I'm going to take this top equation here and I'm going to solve for y. So I'm going to move this bottom one over here. Whoops, that got moved. Okay, and I'm going to solve for y. So I'm going to add 1x to both sides. And I get y, or 1y, equals 1x plus 1. There we go. Now what I do is I take that thing right there and I plug it into this equation. Let's get put in the one there. So I take the y and I replace it with 1x plus 1. So it goes right there. So I get 2x plus 1 times 1x plus 1. And that equals -2. Okay, I have the same equation except I took that y and I replaced it over here. I do the distributive property over, which gives me 2x plus 1x plus 1 equals -2. And if you've done it right, the variable y should be gone. Because now we get 3x plus 1 equals -2. And from here I can just solve for x. So I get 3x equals -3. I divide by 3. So I get x equals -1. Alright, so now I have 1/2 of my ordered pair, and I can simply plug it back into here and find y, because y equals -1 times -1, because that's what x was, plus 1. So get y equals -1 plus 1, y equals 0. So my ordered pair is -1, comma 0. And that's my answer. Now, if we used one of these types of calculators here and we did the graphing method like we learned last time, using the second calculate and then the intersect button, that would actually tell us if our answer is correct or not. Okay, so that's a good way to check your answer. Okay, so let's try another one of these. You want to solve one of them for a variable. Doesn't matter which one. For the sake of argument, I'm going to do something a little different here. So let's do the top one, and I'm going to solve for x this time. So I'll move this. Whoops, they are stuck together. So I'm going to rewrite this over here. 2x plus 2y equals 3. Solve for x, so I'm going to subtract the y over. So I get 2x equals -2y plus 3. Now I divide by 2. Or you can do the heart method, depending on how that looks for you. So I get -1y plus 3 over 2, or the decimal 1.5. Either way will be fine. I take that, and I plug it back into the other equation, not back into the equation you already used. So my x becomes -1y plus 3/2 minus 4y equals -1. I combine the y's, so I get -5y, because it's a -1 and a -4, plus 3 over 2 equals -1. I subtract 3 over 2. Well, I know that this is -2 over 2. -2 over 2 minus 3 over 2. will give us -5/2. And so I divide both sides by -5, or -5/1. Now, if you're getting thrown off by the fractions here, remember you can make these decimals. So the y equals, -5/2. I flip the second fraction, 1/-5. And I get -5/-10. So y equals +1/2. Okay. I take that and I plug it into that equation right there. And so I get x equals -1 times 1/2 plus 3/2. So this becomes -1/2 plus 3/2. And that equals 1. Always important in these problems to remember, always write them as an ordered pair at the very end. So there's my answer. I can check it on a calculator. How are we doing on time? Pretty well. Alrighty, let's try this one on your own. Okay, for this one, I took the top equation and I subtracted the 3y over to get x by itself. So I got x equals -3y minus 11. And I plug that here. So I get 2 times -3y minus 11 minus 5y equals 33. So I get -6y minus 22 minus 5y equals 33. I'm going to add 22 to both sides and then combine the y's. -6 and -5y give me -11y equals 55. Divide by -11. Y equals -5. Obviously, a lot of work gets put into each of these problems. That goes up there. X equals -3 times -5 minus 11. That's 15 minus 11. X equals 4. My answer is 4, -5. Okay. So, most of you are going to be saying, well, I'm never going to do this in my job. I'm never going to have to do this in real life. And you're right. You won't have to do what we're looking at in a job unless you're a mathematician or accountant or something like that. But you will have to think about two separate linear equations at the same time. I'll give you an example. At an MCM boys basketball game, a total of 155 people came to the game. The business office said the school collected a total of $410. If the price of admission is $3 for an adult and $2 for a student, how many of each came to the game? And there's only going to be one solution to this. So you got to figure out how many adults and how many students came if there was a total of 155 people and $410. So try this on your own. Alrighty. Now, this was tough. But what I did to solve this is I thought about making the students X and the adults Y. And so I said if we add X plus Y, students plus adults, is going to be equal to 155 people. And if I said that we had $410, well, it's going to be $2 times each student plus $3 times each adult is going to give us $410. And voila, we have a linear equation. So I would get this to be y equals -1x plus 155, sorry. And I just move the x over. And I plug it into that equation. So I get 2x plus 3 times -1x plus 155 equals 410. And I just solved it from here. 2x minus 3x minus, I need a calculator for that, 465 equals 410. I subtract this over. And I get my x equals 55. I skipped a step there for you. So that means 55 students. Well, if there are 55 students, that means the y has to be 100 adults. Now, if you did this by trial and error, that's fine too, but I'm sure my way was quicker. Alrighty. Look online for your homework assignment. Ask me if you have questions.